Hi sir, I am Rizwan from EC2 section. My roll number is 2340180 My topic is Windbridge Oscillator. Subject name is Electronic Circuits Analysis. Subject code is 23ECE402. Windbridge. The Windbridge Oscillator is developed by Maxwell in the year 1981. The Windbridge Oscillator is based on the bridge circuit. It consists of 4 resistors and 2 capacitors. It is used for the measurement of impedance. The huge amount of frequency is produced by the Windbridge oscillator. The feedback circuit is used by the Windbridge oscillator, and the circuit consists of circuit which is connected to the parallel circuit. The components of circuit have values which give the phase delays and a phase advance circuit with the help of frequency. The Windbridge oscillator is an electronic oscillator and produces the sine wave. It is a two-stage RC circuit amplifier circuit, and it has high quality of resonant frequency, low distortion, and also in the tuning. Consider the very simple sine wave oscillator used by the RC circuit and placed in a conventional LC circuit. Construct the output of sinusoidal waveform is called as Windbridge oscillator. The Windbridge oscillator is also called as Wheatstone bridge circuit. Windbridge oscillator circuit. The Wheatbridge oscillator is used to find unknown values of components. In the most of the cases, the oscillator is used in the audience. The oscillators are designed simply, size is compressed, and it has stable in frequency output. Hence, the maximum output frequency of the Windbridge oscillator is 1 MHz, and this frequency is from the phase shift oscillator. This phase shift of the oscillator is from 180 or 0 degrees. It is a two-stage amplifier with RC bridge circuit, and the circuit has the lead lag networks. The lags at the phase shift are increasing the frequency, and leads are decreasing the frequency. In addition, by adding the Windbridge oscillator at a particular frequency, it becomes sensitive. At this frequency, the Windbridge is balanced with phase shift of 0 degrees. The following diagram shows the circuit of the Windbridge oscillator. The diagram shows R1 in series with C1, R3, and R4 parallel with C2. Here is the diagram. From the above diagram, we can see two transistors are used for the phase shift of 360 degrees and also for the positive feedback. The negative feedback is connected to the circuit of the output with a range of frequencies. This has been taken through the R4 resistor to form the temperature sensitive lamp, and the resistor is directly proportional to the increasing current. If the output of amplitude is increased, then the more current is offer more negative feedback. Derivation on Windbridge oscillator with a circuit diagram. Mod AB is equal to 1, angle of AB is equal to 0 or 360 degrees, frequency F is equal to 1 by 2 by RC. We should find A. If bridge is balanced, Z1 Z4 equal to Z2 Z3. Equation 1. Z1 is equal to R1 plus XC1. Z1 is equal to R1 plus 1 by J omega C1. R2 is equal to Z2 is equal to R2 parallel X C2. Z2 is equal to R2 parallel 1 by J omega C2. Z2 is equal to R2 into X 1 by J omega C2 divided by R2 plus 1 by J omega C2. Z2 is equal to R2 divided by 1 plus J omega C2 R2. Now Z3 is equal to R3 and Z4 is equal to R4. Now substitute these values in equation 1. We get R1 plus 1 by J omega C1 into R4 is equal to R2 divided by 1 plus J omega C2 R2 into R3. At last we get R by substituting and dividing the values, we get R1 plus R1 R4 plus J omega R1 R4 C2 R2 minus J R4 divided by omega C1 plus R4 C2 R2 divided by C1 is equal to R2 R3. J into omega R1 R4 C2 R2 minus R4 omega C1 plus R1 R4 plus R4 C2 R2 divided by C1 is equal to R2 R3. Omega R1 R4 C2 R2 is equal to R4 divided by omega C1. Now omega square is equal to 1 by R1 R2 C1 C2. Now by substituting R1 is equal to R2 is equal to R and C1 is equal to C1, C2 is equal to C, we get omega is equal to 1 by R. F is equal to 1 by 2 pi RC. To determine maximum minimum gain for sustain for oscillations using voltage division rule. Now VFS is equal to V0 S into R2 parallel XC2 divided by R1 plus XC1 plus R2 parallel XC2. We get beta is equal to VFS divided by V0 S. Therefore, we get R2 divided by 1 plus j omega C2 R2 divided by R1 plus 1 by j omega C1 plus R2 divided by 1 plus j omega C2 R2. At now beta is equal to j into 1 by RC and into RC divided by j into 1 by RC and RC minus 1 by RC square into RC square plus 1 plus J2 1 divided by RC into RC. At last we get to beta is equal to 1 by 3 and A beta is equal to 1 and substituting beta is equal to 1 by 3 we get A is equal to 3. Applications. It is used to measure the audio frequency. When bridge oscillator designs a long range of frequency produce sine wave. Advantages. Distortion and testing of power amplifier. It supplies the signals for testing filters. Excitation for AC bridge to fabricate pure tone. Disadvantages. The Wheatstone bridge is not used for the high resistance. The circuit needs the high number of other components. Thank you.